In this problem, we're being asked what values of x will make this rational expression undefined. So a rational expression is undefined when the denominator is equal to 0. So basically, I want to know what values of x will make this trinomial equivalent to 0 when I substitute that value in for the x. So basically, I'm wanting to take this trinomial and I want to figure out when does that equal 0. I'm wanting to solve this equation. And there's lots of ways you can solve this. The way I'm going to show you is by factoring and using the zero product principle. So the first thing I'm going to have to do is factor this trinomial. And I'm going to do that using the AC method. And I'm going to factor over here to the side. So I have 6x squared minus 7x minus 3. So when using the AC method, that's referring to the coefficients in front of each term. The coefficient in front of the x squared term is your A. The coefficient in front of the x term is your B. And the constant here at the end, that's your C. And I'm basically, what the goal of AC method is I'm going to take a trinomial and split the middle term up into two terms so that I'll end up with 4 terms that I can do factor by grouping with. So I have to figure out how I'm going to split up this negative 7x. And there's lots of ways to split it up. It might be negative 8x and 1x, or it could be negative 3x and negative 4x. There's lots of ways I can split up this term, but only one way is going to be helpful. So to figure out that one way, we do AC method. So in AC method, we multiply the A times the C. So in this case, I'm going to multiply positive 6 times negative 3. And when I do that, I get negative 18. So that's going to be my goal number. But I have to keep in mind, so I'm looking for two numbers that are going to multiply to negative 18. But I have to keep in mind that since I'm splitting up the negative 7x, whatever those two numbers are have to add back to negative 7x. So there's lots of things that can multiply to negative 18. It could be 1 times negative 18, 2 times negative 9, 3 times negative 6. It could be negative 1 times positive 18, negative 2 times positive 9, negative 3 times positive 6. Those are my integer combinations that will multiply to negative 18. But I need the combination that adds back to this term I'm splitting up. So those numbers have to add to a negative 7. So when I look at all my combinations, the only combination that does that will be the positive 2 and the negative 9, because positive 2 times negative 9 is negative 18, and they add to negative 7. So those are the numbers I'm going to use to split my middle term. So the 6x squared is going to remain the same, the minus 3 is going to remain the same, but my middle term I'm going to split into a positive 2x and a negative 9x. And the order that I write them isn't important. AC method will work either way because order doesn't matter when we add. So I'm just going to write the plus 2x first and the minus 9x 7. So these two expressions are equivalent. They simplify to the same thing. The only difference is now that I have 4 terms, I can factor by grouping. So that's my next step. So when factoring by grouping, I'm going to group the first 2 terms together, and I'm going to factor out the GCF of the first 2 terms. And then I'm going to look at the last 2 terms and factor out the GCF of those terms. So between 6x squared and 2x, the GCF is going to be a positive 2x. And for the second group, between negative 9x and negative 3, that GCF is actually going to be a negative 3. Anytime your leading coefficient is negative, you want to factor out a negative GCF. So doing that, if I factor a 2x out of the first group, 6x squared divided by 2x leaves me 3x, and positive 2x divided by 2x leaves me 1x. And I can do a quick distribution to check that I factored this correctly. 2x times 3x is 6x squared, and 2x times 1 is 2x. That's looking good. In this group, I'm factoring out a negative 3. So when I do that, Negative 9x divided by negative 3 is a positive 3x. And negative 3 divided by negative 3 is a positive 1. Doing some quick distribution to check, negative 3 times 3x is negative 9x, and negative 3 times positive 1 is negative 3. So I know I factored out the GCF correctly. And if you'll notice when I did that, I happened to get identical binomial factors in the first group and in the second group. So now I'm just going to factor out those binomial factors. So when I factor out my group, I'm going to pull out the 3x plus 1 binomial, and when I do that, I'm left with a 2x from this first group and a minus 3 in the second group. So if I wanted to check it, I could distribute this group to the 2x, and that would give me 2x times the binomial. And I could distribute the binomial to the negative 3. That would give me the negative 3 times the binomial. Okay. But what I'm looking for is the factored form, and that's these two factors right here. If I multiplied this out and checked it, it would get me this original trinomial. So this is the factored form. This is the multiplication problem that is equivalent to the original trinomial. So I can come over here to my equation, and instead of having this trinomial, I can replace it with the equivalent multiplication problem. So 6x squared minus 7x minus 3, that factors to 3x plus 1 times 2x minus 3. Now, I'm going to employ something called the zero product principle here, which is a super nifty principle. Basically, it says if two numbers, a binomial is just a number, this binomial is just a number, if I multiply two numbers together and the answer is 0, I'm guaranteed that one of these numbers had to be 0. You know, that wouldn't work if this was equaling 12, for example, because lots of things multiply to 12. But if two things are multiplying to 0, I can guarantee you one of those numbers has to be 0. So I know that either this term, this factor, which is 3x plus 1, either that's going to be 0 or 2x minus 3 is going to be 0. So my job is to figure out what value of x would make this factor equal to 0. So basically, I set the factor equal to 0 and solve for x. So I'm going to subtract 1 on each side. That adds to 0 and leaves me a 3x on the left. And this adds to negative 1. And then I'm going to divide both sides by 3. That divides to 1 and leaves me an x. So I'm claiming if x is negative 1/3, then when I plug it into this factor, it's going to equal 0. And I could do a quick check. 3 times negative 1/3 is negative 1, and negative 1 plus 1 is 0. And I don't care what it makes this over here. If whatever it is, if I times by 0, my overall answer is going to multiply to 0. So I'm claiming that this is one of my possible solutions. And I'm going to check it in this trinomial in just a second to make sure that when I plug it into the trinomial, I'm really getting 0 as my simplified answer. So we're basically going to do the same thing for this other factor. If 2x minus 3 is equal to 0, I'm going to solve for that, for x. So I'm going to add 3 to both sides. It's going to add to 0 and leave me 2x is equal to 3. And then I'm going to divide both sides by 2. And that is going to divide to 1 and leave me x equals 3/2. So I'm claiming if x is 3/2, it makes this factor 0. And 2 times 3/2 is 3, and 3 minus 3 is 0. But to double check, I'm going to plug this value of x into my denominator and see if I really get 0 when I plug that in. So I'm going to reach over here and grab my calculator. And I'm going to plug each of these values of x into the denominator and see if it really makes the denominator 0. So I have 6 times x, which I'm going to check this negative 1/3 first. So everywhere I see an x, I'm going to plug in a negative 1/3. So it's going to be negative 1/3 squared minus 7 times x. So I'm going to do minus 7 times negative 1/3. And then minus 3. And when I press enter, I'm really hoping I get 0 as my answer. So let's see. 0. So when the question asks for what values of x is the expression undefined, if x is negative 1/3, then it's going to make the expression undefined because it made my denominator 0, and we don't want the denominator to equal 0. Now I'm going to check the other possible solution, which is 3/2. So I'm going to do 6 times 3/2 squared minus 7 times 3/2. And then I subtract 3 and I hold my breath, and when I press enter, I'm really wanting it to be equal to 0, and it is. So this expression is undefined when x equals 3/2 because when I plug it into the denominator and simplify, I get 0. And if the denominator is 0, the expression is undefined.